From unusual contraptions to mind-boggling artifacts, these inventions are proof that ancient engineers were way ahead of their time. Here are the top 15 most mysterious ancient machines. Starting with number 15, Archimedes' Claw. The Archimedes' Claw, a war machine said to have been used by the ancient Greek mathematician Archimedes to defend the city of Syracuse, stands as one of history's most mysterious inventions. This ancient weapon, also known as the Iron Hand, was reportedly used to devastating effect during the Roman siege of Syracuse in 214 BCE. Described by ancient historians like Polybius, the claw was a ship-capturing mechanism that could lift Roman vessels out of the water, capsize them, and create chaos among the attacking fleet. But how much of this story is grounded in reality and how much is simply legend? The truth behind the claw remains as elusive as the machine itself. According to Polybius, the claw was a device that was swung down from the city walls, grabbed Roman ships by their prows, lifted them out of the water, and then dropped them back into the sea, causing them to capsize. The description paints a picture of a machine capable of extraordinary feats of engineering, far beyond what we might expect from the 3rd century BCE. The problem is, we only have these texts to rely on, and they were written by historians who may have been more interested in telling a dramatic story than in providing accurate details. This raises the question, did it really exist? Or was it a product of exaggerated reports meant to magnify the brilliance of Archimedes and the heroism of Syracuse? While the description of the claw's actions are technically plausible, given Archimedes' known expertise in mechanics and engineering, he was a master of leveraging power of simple machines, levers, pulleys, and cranes. It is within the realm of possibility that he designed a mechanical arm capable of lifting and capsizing a ship, especially if ships were small and the conditions were ideal. Number 14. South-Pointing Chariot. The south-pointing chariot, it's one of the most intriguing and forward-thinking inventions to emerge from ancient China. This mechanical marvel, designed to point in a specific direction regardless of how it was turned, served as an ancient form of navigation long before the magnetic compass. Now, what sets this chariot apart is not just its approach to solving a practical problem, but the sheer mystery surrounding its origins. Unlike the regular old compass, which relies on the magnetic field, the south-pointing chariot was purely mechanical. It consisted of a series of gears that were connected to a figure on top of the chariot. Now, once set to a point in a particular direction, this figure would continue to point in that same direction, no matter where the chariot was moved. The genius of this design lies in the use of a differential gear system, a concept so advanced that it's still in use today in modern vehicles. The idea of a self-contained navigational device which could guide people without relying on celestial bodies or magnetic fields was revolutionary. It wasn't just a tool, it was a statement of the capabilities of those engineers, showcasing their deep understanding of mechanics. Now, what makes it so fascinating is how ahead of its time it was. The concept of a differential gear wasn't seen in the West until centuries later, yet here it was, implemented in an ancient Chinese device. The earliest surviving description of the south-pointing chariot comes from the Song dynasty, long after the time it was supposedly first invented. This gap in the historical record adds another layer of mystery to it. Did it really exist in the form described by ancient texts, or were these accounts embellished over time, transforming a simple mechanical device into something more awe-inspiring? Number 13. The astrolabe. So imagine a device capable of determining your exact location, reading the time, predicting your horoscope, and even aiding in decision-making, all within the palm of your hand. Well, this intricate tool, whose name translates from Greek as Star Taker, was a cornerstone of scientific and mystical practice for centuries, widely used across European and Islamic cultures. The origins of the astrolabe are shrouded in mystery, with some evidence suggesting that emerged around the time of Claudius Ptolemy, a renowned Greek astronomer who lived in the Roman Empire during the 2nd century AD. Ptolemy's writings hint at the use of a three-dimensional instrument akin to the astrolabe for making celestial calculations, though the exact details of its creation remain lost to history. The astrolabe likely spread from Europe into the Islamic world by the 8th century, where it saw further refinement, becoming an indispensable tool for scholars, navigators, and astrologers. Typically made from brass, these devices could range in size from as small as a coffee saucer to as large as a trash can lid, depending on their intended use. It consists of several key components: a circular disc called the mater, which houses a series of plates representing different latitudes, a rete or star map that overlays the plates, indicating the position of prominent stars, and a rotating rule that allows for various calculations to be made. On the reverse side, a sighting device could be used to measure the altitude of celestial bodies, providing the starting point for many of the astrolabe's functions. But did it actually work? The answer is a resounding yes. The astrolabe was incredibly accurate for its time, allowing users to make precise astronomical observations and navigational calculations. While modern scientists might view the astrolabe as a primitive instrument, its influence on the development of math and astronomy cannot be overstated. In fact, the astrolabe's blend of science and astrology helped lay the groundwork for many of the techniques still used today in these fields. Number 12. The Coso Artifact. The Coso artifact is an object that stirred up considerable debate and intrigue since its discovery. On February 13, 1961, Wallace Lane, Virginia Maxey, and Mike McKessel, while prospecting for geodes near Olancha, California, stumbled upon what they initially believed to be a remarkable find: a spark plug encased in what they claimed was a half-million-year-old geode. This discovery, if true, would have posed a significant challenge to our understanding of human history and technology. However, a more plausible explanation is far less sensational. The artifact was described as a porcelain cylinder with a 2mm metal shaft surrounded by a hexagonal copper sheath. At first glance, it appeared to be an ancient technological relic. The discovery led to claims that it was an out-of-the-place artifact, which could imply advanced technology predating known civilizations. Now, this notion stirred considerable excitement among enthusiasts who saw it as evidence of ancient advanced civilizations, time travelers, or even extraterrestrials. This excitement was fueled by the assertion that the matrix containing the artifact was a geode, which suggested an age of at least 500,000 years. However, this claim came with significant problems. The purported dating methods and the identity of the geologist involved were never clarified. There were also no notable scientific methods for dating such a concretion at the time, raising more questions about the accuracy of the age. In reality, the Coso artifact was eventually identified as a 1920s-era champion spark plug encased in a concretion, a type of hardened sedimentary deposit rather than an ancient geode. When examined in detail, the metal components of the spark plug showed signs of rust and decay consistent with exposure to the elements over several decades, not millennia. The discoverers had used a diamond-edged blade to cut through the matrix, revealing the spark plug. This action, combined with the artifact's appearance, contributed to all this confusion. The initial identification was also complicated by the fact that the real artifact was lost in the late 1960s, making further verification pretty difficult. However, subsequent investigations, including X-rays and expert opinions from spark plug collectors, confirmed that the object was indeed a spark plug, not some ancient technological artifact. Number 11. The Abydos Helicopter. The Abydos Helicopter, a controversial set of carvings found in the Temple of Seti I in Abydos, Egypt, has long intrigued and puzzled both scholars and enthusiasts. These hieroglyphs, which some claim resemble modern vehicles like helicopters or UFOs, have sparked some debate about their true nature. Were they the result of ancient extraterrestrial visits, or is there a more modern, rational explanation for these enigmatic symbols? In the ancient city of Abydos, the Temple of Seti I stands out for its elaborate carvings and inscriptions. This temple was built between 1290 and 1279 BCE and includes the famous Abydos King List, a detailed account of previous pharaohs. However, it's the so-called Abydos helicopter carvings that have captured our imaginations. Discovered in 1961 by a team of archaeologists, these carvings have been interpreted by some as depicting advanced technology, such as helicopters or even UFOs. This interpretation stems from the shapes and forms of the hieroglyphs, which to the untrained eye might seem reminiscent of modern machinery. According to proponents of ancient astronaut theories, these symbols are evidence of extraterrestrial contact or advanced ancient technology that predated known historical developments. Could these carvings represent actual historical evidence of advanced civilizations or even alien visitors? Well, this theory aligns with the broader pseudoscientific narrative that ancient monuments and artifacts bear witness to advanced technologies and ETs. If the Abydos helicopter were indeed evidence of advanced technology or even ET influence, it would have far-reaching implications for our understanding of human history. It would change established narratives about the development of our technology and the history of human contact with otherworldly beings. However, the more likely explanation, based on scientific analysis and historical context, is that these carvings are a product of artistic and practical conventions rather than proof of ancient spacefaring civilizations. Number 10. The Catapult of Dionysus. So few machines capture your imagination quite like this Catapult of Dionysus. This is a revolutionary device, sometimes dubbed the Ancient Machine Gun. It represents a fascinating leap in military technology. The story of the catapult begins in the 3rd century BC, amidst the bustling arsenal of Rhodes, a Greek island renowned for its military technology. It was here that Dionysus of Alexandria, a brilliant Greek engineer, crafted a weapon that would forever change the landscape of the ancient military. Unlike standard catapults and ballista of his time, the Polybolus was a marvel of engineering and ingenuity. Picture this, a catapult that could fire multiple projectiles in rapid succession without the need for constant reloading. The Polybolus operated on a principle that was, for its time, advanced. It used flat link chains running over pentagonal prisms, speculated to function as inverted gears. A rotating tray fed projectiles into the machine, enabling it to fire bolts at a rate of 3 times faster than the standard Scorpion. So, did this thing actually work? Well, the answer is yes. Historical accounts and modern reconstructions attest to its performance. One 19th century reconstruction by German engineer Erwin Schramm demonstrated the Polybolus's remarkable accuracy. Unlike earlier catapults, which were designed to breach walls and towers, this one was more suited for targeting enemy personnel. In fact, ancient writers sometimes lament the weapon's overkill. Its precision, it meant that it could eliminate enemy soldiers with a degree of efficiency that bordered on excessive. Number 9. The Boeotian Flamethrower. Centuries before the intense conflicts of World War I introduced flamethrowers to modern warfare, an incredible invention was already igniting ancient battlefields. This device, known as the Boeotian Flamethrower, dates back to the 5th century BC, and it's among the earliest known flamethrowers. During the Peloponnesian War in 424 BC, the Boeotians from central Greece wielded this powerful weapon. In the fortified city of Delium, which was under the Athenian control, and the Boeotians unveiled this mechanical innovation. Unlike simple adaptations of existing tech, this flamethrower was a revolutionary design. The Boeotians didn't just keep their creation for testing, they brought it directly onto the battlefield. At the Siege of Delium, they showcased its effectiveness, catching the Athenians, who were used to conventional siege tactics, completely off guard. The flamethrower worked by forcing air through an iron tube that led to a cauldron suspended by chains. This cauldron wasn't filled with ordinary substances, but contained a flammable mix of pine resin, dried embers, and sulfur. When the air from the bellows mixed with those materials, it caused them to ignite, spewing forth a stream of fire. In battle, the flamethrower was devastating, breaching wooden defenses and revolutionizing siege warfare. Unlike the Spartans, whose attempts at using fire in siege failed due to adverse weather, the Boeotians succeeded with their precise and powerful technology. But despite the lack of detailed technical diagrams in the historical records, the mere description of this flamethrower highlights the ancient Greeks' advanced understanding of mechanics and chemistry, even without modern materials like nitrogen or gasoline. Number 8. Stonehenge. Stonehenge, the iconic prehistoric monument located on England's Salisbury Plain, has been a source of fascination for historians for centuries. This massive stone circle poses enduring questions about its construction, purpose, and the logistics of moving its gigantic stones. Dated to around 2500 BC, Stonehenge features towering sarsen stones that stand about 13 feet high and weigh roughly 25 tons. These stones were not sourced locally but were transported over 180 miles from the hills in Wales. The monumental challenge of moving and erecting these stones echoes the mysteries associated with other ancient constructions like the Egyptian pyramids. Recently, some have speculated that the key to moving these massive stones may have been a sophisticated machine, now lost to history. This machine, theorized to exhibit exceptional engineering, would have used a combination of rollers, levers, and other mechanical aids to maneuver the stones. The suggested device featured a hollow beam on a chariot-like frame, equipped with a large bellows at one end. When operated, these bellows would push air through a tube to a cauldron filled with a flammable material like pine resin and sulfur, creating a jet of flame. While primarily a lifting tool, this machine also purportedly moved the heavy stones over long distances. The beam served as a lifting mechanism, while a system of rollers and rockers, possibly made from stone or metal, helped to minimize friction. This setup could potentially move the stones about 1.5 miles per day, meaning the stones could have reached Stonehenge from Wales in just a few months. Moving on to number 7, Archimedes' Death Ray. Archimedes, the renowned ancient Greek mathematician and inventor, is often linked to the legendary Death Ray, a device purported to set enemy ships on fire using focused sunlight. Also known as the Burning Mirror, this invention remains a blend of myth and scientific curiosity, raising questions about its actual existence. Legend holds that Archimedes employed a massive parabolic mirror to concentrate sunlight on Roman ships besieging Syracuse, causing them to catch fire. This device is typically described as being made from bronze or copper shields arranged to focus the sun rays intensely enough to ignite wood. However, historical evidence for the death ray is pretty minimal and inconsistent. Contemporary accounts from Archimedes' time don't mention such a weapon. The earliest references surface in texts several centuries after Archimedes' death, like the one from Anthemius of Tralles around 500 AD. His work on burning glasses alludes to the use of parabolic mirrors by Archimedes, but this comes 700 years after those events. Subsequent ancient authors mentioned Archimedes employing fire against ships, but details are scarce. More comprehensive descriptions appear in later texts from authors like Zonares and Tzetzes, who refer to a combination of a hexagonal main mirror and a smaller auxiliary mirror to concentrate the sunlight. Well, despite the lack of solid historical backing, modern experiments have tested the feasibility of this concept. In 1973, Greek scientist Ioannis Sakas used 70 copper-coated mirrors to ignite a plywood model of a Roman ship from 165 feet away. More recently, in 2005, MIT students managed to set a boat on fire in San Francisco Bay using mirrored tiles, albeit under ideal conditions. These experiments suggest that while theoretically possible, the practical deployment of Archimedes' death ray would have required conditions so perfect as to be impractical for actual warfare, casting doubt on its historical use, despite its intriguing possibilities. Number 6. The Mechanical Monk. The mechanical monk stands as a remarkable creation from the 16th century. Designed by Juanello Turano, the mechanician to Emperor Charles V, this 15-inch tall automation is crafted from wood and iron and equipped to walk, beat its chest, lift a cross, and pray silently. Constructed in the 1560s, it still functions over 4 centuries later. The automaton's significance lies not only in its mechanical capability but also in its backstory. According to legend, after King Philip II of Spain's son recovered from a severe illness, the king, in gratitude for the miraculous recovery, commissioned Turano to create this monk. The automaton represents San Diego de la Sala and symbolizes the king's thanks and religious devotion. Hidden within the structure are all the clockwork components, making the mechanical monk a pioneering example of early automation. Its ability to mimic human prayer movements with its precise limb and head motions is pretty astounding given the technology of the time. Beyond its engineering, though, the mechanical monk also embodies the era's blend of science, religion, and superstition, reflecting the tensions during the Counter-Reformation. It's both celebrated as a miracle and viewed with a hint of the sinister. Currently housed at the Smithsonian Institution, the monk has been the subject of extensive study. X-rays have unveiled the complexity of its inner mechanisms, revealing how each body part functions in a coordinated display of silent prayer. Intriguingly, the components hidden inside are decoratively shaped, indicating that they were crafted not merely for function, but with a reverence for a higher power. Today, the mechanical monk continues to captivate as it did centuries ago, an example of human creativity and a symbol of divine mystery. Its functionality and intricate design keep it as a centerpiece of both historical fascination and some mechanical wonder. Number 5. The Astronomical Clock of Prague. The Prague Astronomical Clock, or horloge, is a marvel of medieval engineering that stood as a symbol of the city's heritage since the 15th century. More than just a timekeeping device, the horloge serves as a celestial calendar and a mesmerizing piece of art, enchanting visitors with its mechanics and its storied past. Located on the southern wall of Prague's Old Town Hall, it was constructed in 1410 by Mikuláš of Kadaň, with later enhancements by Jean Rouget. It exemplifies the era's advanced craftsmanship and its technological knowledge. It tracks the sun, moon, and stars, and displays time according to various historical systems, including Babylonian, Old Bohemian, German, and even sidereal. The clock comprises 3 primary parts: the astronomical dial, the calendar dial, and some animated statues. The astronomical dial is the core. It presents the current positions of celestial bodies and includes details like lunar phases and zodiac signs. Below this, the calendar dial, added in 1490, features medallions for each month, zodiac signs, and notable religious feast days. The entire assembly is framed in a Gothic casing, decorated with symbolic carvings and figures, including a skeletal death that tolls a bell each hour, reminding the viewers of time's relentless march. Surrounding it is a legend as intriguing as the clock itself. It's said that after completing it, clockmaker Mikuláš was sought after by foreign dignitaries who wished to replicate his work. To keep the horloge unique, local officials allegedly blinded him to prevent him from creating another one. According to folklore, in a tragic act of defiance, Mikuláš sabotaged the horloge by leaping into its gears, cursing it to malfunction if anyone else tried to repair it. This tale has a pretty cool layer of mystique to the clock, blending history with the supernatural. Number 4. The Pigeon of Archytas. Archytas of Tarentum, a philosopher, mathematician, and statesman from the 4th century BC, is celebrated for his multifaceted contributions to early science. Among his inventions, the flying pigeon stands out as possibly the world's first autonomous flying device, blending principles of philosophy, mathematics, and engineering. Archytas was born in 428 BC in Tarentum, now part of southern Italy. A proponent of Pythagorean teachings, he made significant strides in mathematics and mechanics. His creation, the flying pigeon, crafted between 400 and 350 BC, was a pioneering automaton, and it's often considered the earliest example of a robot. This steam-powered wooden bird was designed to mimic the flight of a real pigeon. It was hollow to keep it light and had an aerodynamic shape, enhancing its ability to glide. The pigeon's body was cylindrical with extended wings and a pointed beak-like front to reduce the air resistance. The propulsion of the flying pigeon was its most innovative feature. It utilized steam power, generated by heating water in a sealed boiler within the pigeon. The steam expanded into a bladder, building pressure until it was released and propelling the bird into the air. The mechanism allowed the pigeon to soar hundreds of feet before gravity brought it back down to Earth. This invention was not only a marvel of mechanical engineering, but also an early exploration of aerodynamics and propulsion. While the specifics of Archytas' inventions are not well documented, the legacy of the flying pigeon as a significant advancement in the understanding of motion and mechanics remains influential, highlighting his role as a pioneer in the study of automated flight and robotics. Number 3. The Ornithopter. The ornithopter, from the Greek words ornis, meaning bird, and pteron, meaning wing, is a concept for an aircraft that achieves flight by flapping its wings, much like birds, bats, and insects. This fascinating idea has intrigued many throughout history, but gained significant attention with Leonardo da Vinci during the Renaissance. Da Vinci, a master of observing nature, became deeply interested in the mechanics of bird flight. He meticulously recorded how birds manipulated the air and their bodies to soar, leading him to design his own version of an ornithopter. His concept featured a human pilot lying on a plank, manipulating large, membranous wings through a system of hand levers, foot pedals, and pulleys. Despite the brilliance of his design, though, Da Vinci faced a fundamental challenge. The human body isn't strong enough to power such a device. The ornithopter, as conceived, would have been too heavy, requiring more energy than a person could physically produce. Thus, Da Vinci's dream of human-powered flight remained unrealized in his lifetime. Nevertheless, Da Vinci's designs inspired many future inventors. Throughout the 19th and early 20th centuries, European inventors experimented with various ornithopters, some powered by rubber bands, steam engines, or even internal combustion engines. However, those attempts generally failed to produce practical aircraft. A notable development occurred in the 1930s with Alexander Lippisch and the Nazi Germany's National Socialist Flyers Corps. They built ornithopters powered by internal combustion engines, integrating small flapping wings with fixed wings to achieve the necessary balance. These efforts marked some of the most successful attempts to create flying ornithopters, though they remained experimental and didn't lead to widespread practical use. Number 2. Ismail al-Jazari's elephant clock. Ismail al-Jazari, a medieval polymath from Mesopotamia, was a pioneer in engineering, mathematics, and art, significantly influencing the mechanical engineering field. His most celebrated work, the Book of Knowledge of Ingenious Mechanical Devices, details 50 of his inventions, with the elephant clock being among the most renowned. This clock not only serves as a technical marvel, but also as a cultural amalgamation and beacon of human creativity. Living during the Islamic Golden Age, a period of profound advancement in science and culture, Al-Jazari's creations mirrored the intellectual spirit of his time. These inventions blended functionality with artistic beauty. This clock was more than a timekeeping device, it was an elaborate piece of machinery that incorporated diverse cultural elements, reflecting Al-Jazari's appreciation for global cultures. The clock operated on mechanical and hydraulic principles, with its main timing mechanism hidden inside the elephant's body. Now, this mechanism consisted of a water tank and a floating bowl with a tiny hole, gradually sinking as it filled with water, taking approximately half an hour to complete the cycle. When the bowl sank, it triggered a sequence of mechanical events that reset the clock and marked the time. Atop of the elephant was a tower holding a seesaw mechanism linked to the bowl, and when the bowl sank, it pulled a string that tipped the seesaw, dropping the ball into a serpent's mouth carved into the tower. This caused a chain reaction. The bowl was reset, a figure in the tower struck a drum to signal the time, and the serpent returned to its starting position to repeat. Today, modern reconstructions of the elephant clock, such as those displayed in Switzerland and Dubai, continue to enchant people. These replicas celebrate the ingenuity of Al-Jazari's design and the timeless appeal of his work, allowing a new generation to appreciate the sophistication and beauty of ancient engineering. Number 1. Da Vinci's Automaton Knight. Leonardo da Vinci, renowned as a visionary across art, science, and engineering, was born in 1452 and epitomized the Renaissance spirit. Among his diverse inventions, the mechanical knight, also known as Leonardo's Knight, stands out for its design and significance. It's created around 1495, this humanoid automaton was capable of movements such as sitting, standing, and manipulating its visor, making it a pioneering example of early robotics. This life-sized automaton was encased in a suit of German armor and operated through a complex internal system of pulleys, cables, and gears. It was divided into two main sections, the upper and lower body, each with its own control mechanisms. The upper body could move its shoulders, hands, elbows, and wrists, enabling actions like arm raising and visor lifting. The lower body's movements included the hips, knees, legs, and ankles, allowing the knight to sit and stand. Leonardo's deep understanding of human anatomy greatly influenced the knight's design. His anatomical studies informed the accurate placement of joints and realistic range of motion, making the knight's movements surprisingly lifelike. This blend of anatomical precision and mechanical expertise resulted in a creation that was both functional and eerily realistic. The automaton was largely forgotten until the 1950s, when Leonardo's sketches and notes were rediscovered, revealing the breadth of his mechanical ingenuity. This led to a resurgence of interest in his work, culminating in several modern reconstructions of the knight. In 2002, roboticist Mark Eling Rosheim constructed a fully operational model based on his original plans. This modern iteration was capable of walking and waving, actualizing Leonardo's division in a way that seemed unfathomable in the 15th century. Rosheim's work with Leonardo's designs even influenced robotic projects at NASA, demonstrating the lasting impact of Leonardo's innovations on modern science and technology. Thanks for watching, everyone. I will see you next time. Thank you to our channel members.